In this video, we are going to look at the errors that can be made when we make a conclusion from a hypothesis test. Now, we can make a very good comparison between legal proceedings and the performing of a statistical test. With court proceedings, then, there are four possible outcomes. If the accused is innocent and the verdict is innocent, then we've got justice has been done. If the accused is innocent and the verdict is guilty, then the court has made a mistake. And in theory, the British, or certainly the English and Welsh legal systems, are set up in such a way to try to minimise the chance of this mistake being made. So our court system tries to avoid, if possible, the mistake of saying that somebody is guilty when they are actually innocent. If, on the other hand, the accused person is guilty and the verdict is innocent, then the court has made a mistake. And in aiming to minimise the chances of the other type of error, it's quite likely that this mistake may be made quite frequently. If the accused is guilty and the verdict is guilty, then we're happy. Now, it is worth emphasising the fact that our system attempts to ensure that innocent people will not be found guilty of crimes they didn't commit. But in protecting the rights of innocent people, there is a considerable risk that people who are really guilty may get away with their crime simply because the weight of evidence against them is simply not strong enough. Now, if we now move across to our hypothesis tests or significance tests, again we have a similar table of four different possible outcomes. It may be that the null hypothesis is true and the significance test decides that it's going to accept the null hypothesis because there isn't significant enough evidence to support the alternative hypothesis. And in that case, the significance test has given the correct answer. Similarly, if the alternative hypothesis is true and the significance test decides to accept the alternative hypothesis, then the significance test has given the correct answer. So in those two cases, we are happy that the significance test has given us the correct conclusion. However, the other two cases are going to represent errors. If the null hypothesis is true and the significance test accepts the alternative hypothesis, then the significance test has given a wrong conclusion. The procedure of significance tests mean that the chances of making this mistake is small and is known precisely. It's simply the significance level, or to be precise, the exact significance level of the test. An error of this kind is called a type 1 error. So a type 1 error is the mistake of accepting the alternative hypothesis when the null hypothesis is in fact true. This will happen when the value of the test statistic lies in the critical region, and the probability of this happening is precisely the exact significance level of the test. The second type of error we've got is that the alternative hypothesis is in fact true, but the significance test accepts the null hypothesis. And again, that is an error. And it's important to realise that in aiming to minimise the chances of the other type of error, it is recognised that there may be a high probability of making this second type of error. So the formal definition, we have a type 2 error is the mistake of accepting the null hypothesis when the alternative hypothesis is in fact true. The probability of making such an error is impossible to work out unless we know the way in which the alternative hypothesis is true. The probability of a type 2 error may be quite high. Right, so let's now look at these errors in terms of some of the questions that we've looked at before. So we're back now to the example of the production line, where the production line has changed its process. In the past, it used 98% of the production past quality control, and after a cost-saving change to the production line, we've produced a test to determine whether there has been a reduction in the quality of the output. The significance test part of that question we have dealt with before, and there is the significance test, and if you can't remember seeing that, you need to go back to the video in which we considered significance tests using critical regions. Right, so the probability of the type 1 error is the probability that we accept the alternative hypothesis when the null hypothesis is true. That means the value of the test statistic has got to be in the critical region when the null hypothesis is true. In this particular case, the critical region was x is less than or equal to 26. When the null hypothesis is true, and when the null hypothesis is true, x has got the binomial distribution 30, with n equals 30 and p equals 0.98. And we've already got the probability of that happening, and that is 0.0029. So the probability of a type 1 error in this case is 0.0029, very small probability. This is the probability of making the mistake of concluding that the probability of passing the quality control test has decreased when in fact it is still 0.98. Probability of a type 2 error is the probability that we accept the null hypothesis when the alternative hypothesis is in fact true. The critical region for the test is x is less than or equal to 26. So the null hypothesis is going to be accepted if x is bigger than 26. In this example, we know that the alternative hypothesis is true because we've been told that the value of p is 0.90, not 0.98. So what we've got to work out is the probability that x is bigger than 26 when x has the binomial distribution with n equals 30 but with p equals 0.9. That's the same thing as 1 minus the probability that x is less than or equal to 26 when x has the binomial distribution with n equals 30 and p equals 0.9, and I can obtain that directly from my calculator. So that's 1 minus 0.3526. So we've got 0.6474 for the probability of a type 2 error. Let's now move on then to a second example. In the 2019 election, a political party, which we will call the Yellows, gained 26.7% of the vote in a constituency. It wishes to determine whether there has been an increase in the level of support for the party since the election. Gareth has decided to conduct a survey of 40 voters from the constituency and has stated that he will conclude that there has been an increase in the party's support, provided the sample contains at least 16 people who support the Yellows. So viewing this as a hypothesis test, first of all we need to state carefully the hypotheses that are being used in the test. Well, we should certainly start by just defining the variable that we're using, we'll let P equal the probability of a randomly chosen person supporting the Yellows. The null hypothesis is going to say that there has been no increase. In other words, we have got P is 0.267. Whereas the alternative hypothesis is going to say that there's been an increase in the proportion of support for the Yellows, so there's been an increase in the probability of a randomly chosen person supporting the Yellows. So we're going to say the alternative hypothesis is P is bigger than 0.267. We're now told that Gareth obtained 18 party supporters in his sample. And earlier on in the question we were told that if the sample contains at least 16 people who support the Yellows, then he will conclude that there has been an increase in the party's support. We're asked to describe the statistical error that Gareth might have made in drawing this conclusion and the probability that he made that error. So Gareth is concluding that the support has increased, but it is possible that it hasn't. So he may have accepted the alternative hypothesis when the null hypothesis is in fact true, and this is a type 1 error. Now the probability of making a type 1 error is the probability that x is in the critical region when the null hypothesis is true. Now we're told in the question that the critical region for the test is x is greater than or equal to 16, because Gareth is going to accept the alternative hypothesis if the sample contains at least 16 people who support the Yellows. If the null hypothesis is true, then x, the number of people who support the Yellows, will be binomial with n equals 40 and p equals 0.267. So we can say that the probability of a type 1 error is the probability that x is greater than or equal to 16 when x is binomially distributed with n equals 40 and p equals 0.267. Which is the same thing as 1 minus the probability that x is less than or equal to 15 when x is binomial 40, 0.267, which we can use our calculators for, and that gives me 1 minus 0.9536, in other words 0.0464. So we've got the probability of a type 1 error is 0.0464, so it looks as if Gareth may have set this test up as being a 5% significance test. James conducted the same survey a few weeks later in the same constituency. Due to malpractice by other political parties and the inspirational leadership of the leader of the Yellows, the level of support had by this time risen to 38.9%. Explain what is meant by a type 2 error for James's test and find the probability that James makes a type 2 error in conducting his test. Well, a type 2 error is the mistake of accepting the null hypothesis when the alternative hypothesis is in fact true. So, the probability that James makes a type 2 error is the probability that he accepts the null hypothesis when the alternative hypothesis is true. He is going to accept the null hypothesis if the value of x is less than or equal to 15. We know the alternative hypothesis is true because we know that p is now 0.389. And if p is 0.389, then we have x being binomially distributed with n equals 40 and p equals 0.389. So we can say that the probability that James makes a type 2 error is the probability that x is less than or equal to 15 when x is binomial, n equals 40, p equals 0.389. And we can obtain that probability directly from our calculator. It's 0.497. So that concludes our look at errors involved with hypothesis testing.